I'm Jonathan Halstuch. I'm the CTO and co-founder of RackTop Systems, and today I'm going to talk to you about Zero Trust Cyberstorage. So a little bit about RackTop. We've been around for over a decade. We're headquartered in the Washington, D.C. area, but we have presence across North America and deployments across the globe. 100% of our support is based out of the U.S., and we are based, as Eric mentioned, coming out of the DoD and the intelligence community. And we've used that experience and put that experience into our product to help defend our customers' data against nation state type attacks and any hacker for that instance. So the company is RackTop. The product is the BrickStor security platform, or BrickStor SP for short. And it's the only end-to-end cyber storage solution. And it can actually stop an active attack, like a ransomware attack against your unstructured data on a file share. And it can also detect things like an insider threat and stop that as well. And not only do we detect and stop those attacks, but we can also point out what files might have been affected during the attack, so you can quickly restore back to the version of that file before the attack. So if you're hit with ransomware and the attack was able to successfully encrypt a few files before we stop it, we can show you what files were affected and then quickly restore those files for you through the interface from immutable snapshots. And I'm going to show a demonstration of these features throughout this presentation as well. And then because we have all these security controls in place, an important part of compliance is demonstrating those controls are in place. So we want to be able to enable our customers to demonstrate continuous compliance with various compliance regimes, whether it's HIPAA, SOX, whatever. They all kind of mostly stem from the NIST risk management framework and focus around similar things like privileged access management, replication, DR, things like that. And so we have the reports built into the UI to make it easy to demonstrate compliance. And we deliver our solution as a software-defined NAS. So we're in the data plane, we're holding that data, but it's software-defined. So it can be deployed in a various number of manners. And I'm going to show you those deployment options in some later slides as well. So something about the BrickStor SP to think about, and I think some of its advantages are, we are in the data plane. So we're able to analyze everything as you're reading and writing data over the file protocols like SMB and NFS. So you can't circumvent us. You have to get and come through us in order to get to the data because the data lives on us. One advantage though is it's agentless. You don't have to deploy anything special on the clients. It's all just evaluating the behavior of what's happening over those file protocols. Because we're auditing all that, we have a complete visibility into who's doing what and from where. And in the user behavior part, you'll see that we're capturing the IP address of the client you came from, the user account you used, the file operations you performed, whether it was read, write, rename, did you read the whole file and all that kind of stuff. And then we're using that information and analyzing that as part of our active defense capability to determine what type of action we're going to take, whether we're going to allow that, if we're going to alert on it or potentially block it. And it's all self-contained. It doesn't rely on external systems. So we can be very fast. We can do things at the speed of the operations of the end user and not rely on outside systems or outside privileged accounts. And we can have very granular access controls, which I'll show you in the demo as well. And the good thing is it's a drop-in replacement for your existing file shares or NAS, and it can integrate with your existing security ecosystem. So it's nothing disruptive to how people operate, and it can feed into your existing security operations center. So I want to talk a little bit about the CISA Zero Trust Maturity Model. And last year, CISA put out this maturity model, and I think it's important to note that the fifth pillar is data. And out of the box, we meet all of the requirements for the highest level of maturity, which is level 5, for their maturity model for that data pillar. A lot of organizations spend and invest in those first 4 pillars, but may not be making the investment in the data pillar. But it's only a complete solution if you're making investments across all the pillars. For instance, you could have multi-factor authentication, but if those credentials get compromised, you could potentially have unfettered access to a traditional or legacy file store. With a cyber storage solution like BrickStor, we're your last line of defense. So even with compromised credentials, we could notice that the behavior is abnormal, like you're trying to run a ransomware attack against it with a privileged account and stop or block that. And what I mean by zero trust, or how we're implementing zero trust, in everyday terms, if you think about credit cards, that's a pretty good example of in everyday life how zero trust works, right? The bank gives you a credit card, you then start charging at places and they evaluate, are they going to allow that transaction to go through based on the size of the transaction, where you are, time of day, is that your normal behavior pattern? If it looks abnormal, they stop the transaction and make yourself prove that you want that transaction to go through, and then they let it go through. So we're doing the same thing for file operations. So traditionally, if you were giving access like read-write permissions to a particular folder, you'd have those permissions to read and write files to that folder until somebody removed access to that folder. With a zero trust approach, we give you access to read and write to that folder, but then we're evaluating each file operation to determine, are we going to let that go through based on how much data you're looking at. Maybe if you just tried to read a ton of data, you're trying to steal data, or if it looks like you're trying to encrypt the data like a ransomware attack, we could alert or we can actually block it. So we're evaluating for trust on each file operation. And we can do that at the speed of operations without slowing down performance and the user experience. And so that's what we mean when we talk about zero trust. And we're giving you those visibility and analytics built in so you can see who's doing what and go look back. So if you become suspicious about a user later, you can look back and say, what was that person doing, or what have they looked at, or what have they accessed? And you can tie this into the rest of your security orchestration and automatic response type framework. So we can be feeding logs into that system and it can respond back to us and tell us what to do. And because we're doing it as you're reading and writing to the system, you get real-time governance. There's no delay or latency to the time to insight. Sometimes if you implement a third-party compliance tool that scans file activity or audit logs afterwards, there could be a delay between the time the event occurs and the time you can make a decision or know about it. And so I have this animation which takes the NIST zero trust architecture diagram and shows kind of what we're doing in real time and what we mean by that. So we're able to actually enforce policy. So in this case, you have a subject using a laptop that is accessing a file share, right? As they try to go access that file, we're then, we're talking to Active Directory and saying, does this person have permission to read this file or write the file? All that's integrated there. We're forwarding logs to the SIM. And then we're determining based on that user behavior activity and the trust, do we allow that file operation to happen? In this case, we do. If not, we could block them based on their IP or user account as well. One of the things we've tried to do is also simplify the configuration. We want to be secure by default and compliant. So out of the box, it doesn't take an expert to provision storage capacity or maintain the system, because obviously there's a global shortage for talent. It's hard to find expert cybersecurity experts. And so we want something that any IT generalist can use and know that it's being implemented correctly and the same every time. And so we've made it a simplified UI because obviously, lots of security breaches happen because of a misconfiguration or human error. So we want to eliminate the chance for that. And we've eliminated the need to understand a lot of the complexities around storage, which can have a lot of knobs, and made it very simple through a UI that anybody can just provision based on the workload of why they're provisioning the storage to do it. And when anything's out of compliance, like normally this should be set this way, but it's not, we alert you and show you this is the difference. Do you want to put it back into the way it was before? This is the user interface. And in this case, I'm connected to a system back in DC, and we have a bunch of shares over here. You can actually see, I can actually browse to those shares. I can see the same thing. Basically, it's showing you what's shared out here. The shield means that the data set's encrypted, and each data set can be uniquely encrypted. This symbol means it's an SMB share. That symbol means this is an NFS share. So we can share out the same data via both protocols at the same time. So you can access the data from either platform. And so now I'm going to go and create a new data set today for this demo. And this is what I meant with the storage profile. You don't really have to know a lot about storage. You just have to know, hey, what kind of workload am I going to be doing? So for this, I'm just going to do a general file system. I'm going to turn on data set encryption. We do support encryption for both data sets. And if we're using FIPS self-encrypting drives, we'll manage those drives. And we will be the key orchestration piece. So we can store the keys and generate the keys, or we can talk to an enterprise key management server. So that's KMIP compliant. So we'll just request the keys from them. They'll provide us the keys, and then we'll just say we need a key. So I'm going to share this out by SMB. So I have all the normal settings you would want for a file share, but we also can have host-based access control in addition to identity-based access controls. This is important because in a lot of organizations, they might have a shared system. So if you think about a municipality, they might buy one system for the courthouse, for the health department, et cetera. They're all on different networks and in different buildings. So we can segment this data set to only be available to the courthouse if it's courthouse related data, or the health department if it's health department data, in addition to providing identity control. So further segmenting what's available there. And then we integrate with Active Directory and LDAP users and groups. So you can look up, who you want to add to this group. So in this case, I could do like all domain users, or I could choose a particular user like my demo account. It just depends on who I want to give access to. So in this case, I'll give domain users access. I create this. And then now I see on the right, I'm pre-modeling what the effect of the changes are going to be. I can tie this to a change control or ticket so that I know this was an approved action to actually change this. So everything we're doing as an admin is being audited on the system as well. So it can be tied back. So now it's going to go out and make those changes. And when it does that, I'm basically going to be able to see that folder show up here as well now. So now we see the security field day folder, and I can start to put data in there like you would expect, create files and all that good stuff.
These can be done, be it on a local box, or these can be done over via like the network shares, because I'm seeing here.
Yeah, so
IP.
Yeah, we're basically a NAS or a file share. So we're shared file storage. So we wouldn't be your local disk. We would be that. Yeah, exactly.
A bit about auditing. You can. I'm assuming you can send that data somewhere. Like if I had.
Yes. Exactly.
Integrate it that way.
Yep. So everything's in a standard syslog RFC 5424 format. So you can send it to your favorite, like Splunk or Elk or whatever. Yep. And the other thing that I did, when I provisioned that data set, we have data protection policies as well. Those data protection policies set how frequently we're taking snapshots of the data on there and how long we're retaining them, and if we're replicating them to another system as well for DR. Because a cyber attack, obviously you want to prevent the attack. Things like a hurricane, you can't really prevent the hurricane. The whole building's gone, you need a second site. So it facilitates both things. But if I go into here, basically we have data protection policies. So it automatically starts protecting your data and taking snapshots so that you can go back to previous versions of the file. And one of the capabilities we have built into our product with the snapshots are what we call rolling snapshots. Think of it as like a DVR. So if somebody accidentally makes a mistake, they themselves can go back to the previous version of that, and I'll show that. But if obviously there's a security incident that happens, we can go back to those previous versions of the file and just take out the files that were affected and restore them to the pristine version. So you don't have to go to backups or something else to try to recover. So it makes it very easy to do that.
This is all applied on the folder level, or can you do this also to single files?
At this level, it is done at the folder level. Yep. So you can have a hierarchy. So in this case, you see there's multiple folders. I can basically apply it as a hierarchy, so everything's like this down that, but we start at kind of the folder levels, the most granular we control, but then permissions and stuff can be done at a file level, but the snapshots is at a folder level. So.
Problematic is sometimes when user moving from one folder to the other folder, then all the content is changed and is following under a different policy if a certain user has access to both of them. Yeah.
Yep, exactly. So one thing you can do though is you can either, if they're different policies, you can have different policies on different folders, so you can choose that. You'll also be able to see with user behavior that if they're moving data between folders. And with things like context security labels, you could also say like, this folder is approved for, let's say, HIPAA data or healthcare data, but this one isn't. And you can start to see like data, you're having a data spillage issue where data is going into folders it shouldn't.
So it's almost like splitting it off into a share. And I was just telling them yesterday, because we had a similar issue. I worked at a healthcare organization. Things were in one folder that shouldn't have been, and it was like social security numbers, and it all just fled over when I was out for the week. And I'm like, yeah, that's a problem.
Exactly.
You have to go and break it in all these sub shares. And
yeah.
And users will move data and they'll create all these new folders called new folder.
Some people have more strict requirements about how you clean up from a data spillage event. The cool thing with this is, I mentioned how these are all encrypted with a unique key. So let's say somebody puts bad data in with good data. What you would essentially do is create a new data set that's encrypted. You take all the good data out of the where you had the mixed data and put in the new data set. And then you basically could crypto erase this old data set just by destroying it. You'll destroy the key and the contents, and you've shred the data that it would be compliant with the NIST standards for media purge. So,
and your logging would be able to tell me who downloaded anything.
Yes, and that's what we're going to go to next. So you're perfect to have it. So basically,
within the data classification, obviously you can specify. You demoed that you can specify the folders, but is there any like bit where it's like I would mark something as classification level, and it would alert if it's trying to be put, or block it from putting it in the wrong folder, or?
We don't have that today, but that's something that we want to be able to do in the future to show, to prove. There's a couple of things, right? I want to prove I don't have any of that data and report on that. So there's nothing with that tag in that folder. Then the other would be somebody tries to put a tag that shouldn't, that's like in an unapproved folder. We don't have that today, but we definitely think that that's something that would be valuable because we see that happen. Yeah.
I have one more random question. I had a use case many years ago. It wasn't a happy use case. It was scanning. I'm sure you can read between the lines. It was scanning all of the images on people's laptops that worked there, looking for a certain type of image.
Yep.
Does it do anything like that?
This doesn't do that, but people do use they use our system for computer forensics where they'll dump the image, and then because we have performance, we can be very performant, so they can cut up the image and go look for that data. Mm-hmm. And the other good thing that obviously, especially if you're going to prosecute or do something, is we can show data provenance in the chain of custody so that you know who did what and what was touched. So
lovely.
Yep. Yeah, we have that as a use case, especially municipalities and elsewhere. Yeah. Mm. And so one of the capabilities we talk about is user behavior analytics or user behavior auditing. So basically, we can give you that kind of digital painting of what's happening in your environment. And so there's a security aspect to this, which is maybe we get suspicious about somebody and we think they might have been looking at a bunch of data after they resigned or something like that, or they're getting nosy and looking at folders and images that they shouldn't be, or they're interested to see if there's some celebrity at the hospital and they're looking through that. We have complete visibility into all those operations, and I'm going to show you that. But there's also, from a non-security standpoint, just a like kind of overall data management and data risk part of this too, which is I have this data, I'm storing it. Is it on an expensive tier, or can I archive it to the cloud? Is it who's actually using it? Who's the community of interest? And is it widely exposed? Maybe I have a lot of data that I see that nobody's really accessing, but it's high risk. Maybe I don't want to get rid of the data, but I want to lower the number of people that have access to that data because nobody really needs access to it because nobody's been looking at it. And when they do, we can open up the access to. So this plays into that. So back to my. So as I start to do stuff over here, I created that one share. I created the stuff. If I start opening up files here, everything I'm doing is being tracked and audited. So anything that happens is audited in our user behavior. And so we're capturing that in the UI, but it also can be forwarded to a SIM like Splunk and things like that. And that's also, I'm going to talk a little bit more like that in future slides about what we can do with it, sending it off box. But so we're going to see, the activity. We can see if there's a high volume of activity through, this heat map. We can see the most active users and the most active paths, but then we can also drill down into see the raw operations. And so you can see the protocol we use. So in this case, SMB, because I was coming from my Windows laptop, the time, the account that was used. So I'm using this Johnny at RackTop demo, and then the IP of my laptop over there. And then the operations, right? I read the file, then I open the file in this case, and then I write to the file, the size. So we can see, am I reading the whole file or just a portion of the file? Some of these behavior patterns become important too when you talk about malicious activity or when people are scanning things or manipulating things too. And to your point, right? Let's say you have an overexposed share. I accidentally gave the whole domain user access to the data set, but I shouldn't have done that. Now I want to know who had access to that share. I can filter down to a particular data set, or I can go to a particular path. So I can narrow down not just to a data set, but to a particular path. Or if somebody moved a file, I can do a search to see, I'm looking for a missing file. I want to see where that is. I can do that too. So you have a lot of granularity into how you look for files or search this stuff too.
I've seen some not competing solutions in this space, but unrelated products that do some neat visualization in terms of baselining and patterns visually of who's accessing what. Is that something you guys are?
We don't have that today, but I've seen that in some of the stuff. That's something we could do, or we can feed those into some dashboards like Grafana and third-party tools and do that. Yep.
Oh, cool. Thanks.
Yep. And so here you can see I filtered on that file, so I could look for that file. if somebody dragged and dropped the file, I could see who that did that and attribute it to that. But then also, if I was suspicious about a particular user, like maybe Cindy resigned or Dave, I happen to know he's a character. If I'm wondering what he's done, I can actually filter and just look at his access and what he's been accessing lately or for a period of time. And this is completely exportable too. So I can export this to a report that I could give to somebody or an investigator or things like that as well from here too. And we have PDF or CSV or JSON, so it's flexible as well.
You mentioned earlier the bit about reviewing. Is that something you can automate where it's like after X amount of time, if nobody accesses this?
Shut
Like
it.
scheduled
Yeah.
audits?
Kind of, yeah.
We do scheduled reports. We don't have like a scheduled lockdown, but that's something that could be done. Or you could tie it into like if you did have a SOAR that you want, you feed it to that, and then that sends an API request to us to say change the access. So
Well, the use case I was thinking of is if I had like contractors, sometimes the people that hire the contractors aren't best at giving a notice that they're not.
they've left.
Yeah, or you know, if you have highly sensitive data, nobody's accessing it. It makes sense to automatically lock it down. So that was
I agree. That's a good idea. Definitely something we could do, and I think would be worth doing for sure. Yeah,
cool.
We don't do it today, but I like the idea for
It's
sure.
like we talked about yesterday, they give them access to the wrong shares and stuff that they shouldn't have,
that too.
which would avoid all of that.
But it would also help with the role-based access. If you realize nobody in the team has accessed anything on that share, maybe you've got the role defined wrong.
Yeah, and we can do reports that show you like, hey, here's the 30, 90, who's accessing and who's not.
Yeah.
Yep. Audit, we've seen auditing people that's been doing for a while. One thing that we're able to do is do the audit without sacrificing user experience or application performance, which is important. But the real exciting part is the active defense piece, taking that audit information and responding to it based on the user behavior and that kind of zero trust model, being able to do active policy enforcement. And so we want to stop things like data exfiltration or ransomware attacks, which have become popular. But obviously with ransomware, a lot of times they're trying to steal the data beforehand. So we want to alert on that. Or if you look at the SolarWinds Sunburst type attack, where they get into your network through the supply chain, right? They're now in the environment and they are basically on the network monitoring system that has access to all the systems because it needs to monitor them all. So it's not unusual. It's talking to a lot of systems. They try to escalate to admin privileges and then go look around the network to see what files they could access. I'm going to show you how we could detect an attack like that even and alert you as to why there might be malicious activity going on. The other cool thing about active defense is that not only do we stop and block the attack, but we only block the affected machine or the affected user. We don't block everybody. It's not like the Colonial Pipeline where they shut the whole pipeline down to protect it. We can contain the attack, which is what you want. You want cyber resiliency, because if you think about a healthcare organization, if you're seeing patients and only one user's machine's infected or one user account's been compromised, we want to block and stop that user and account. And we want the other doctors to keep working, right?
That's what the one sensor when I used to work, we used Carbon Black and we implemented it. It just had like the kill sensor. So what it would do was it would quarantine the box or the machine and it would just connect to Carbon Black server and vice versa. You couldn't get on the network. You couldn't do anything. It just locked it right down.
Yep. So we're doing the same thing from the source side, right? So that, and I feel like there's two endpoints over that, right? There's that client side and then there's our side.
Yeah.
And so you want to protect both. It does integrate with your SOC too, right? So this kind of shows you what happens in kind of a little diagram. To your point, is that we do feed into the SIM and SOAR. So we want to become part of that security ecosystem and really become another sensor for you. Because I think right now you have some blind spots potentially that you can't see, right? Because not every device has an agent on it, right? The SolarWinds network monitoring appliance probably doesn't have a compatible agent. People don't always put agents on things like domain controllers, but that's what hackers tend to go for a ransomware attack. So we want to be another sensor to give you more high fidelity information about what's happening in your environment. And in addition to feeding a SIM and a SOAR with our webhooks, we can integrate with things like Slack or PagerDuty to alert you as to what's happening. And so your team can take notice of that and then follow up based on those alerts.
So is this one direction only? Or can we communicate back? Because like, what if I'm worried about false positives. I don't want to lock people out right away, but I want to know about that. And
Yep.
let the higher level systems say, are there enough signals to lock this person out?
Yes. So we can basically just feed you the information. There's a rules engine within us that says, based on this, we're going to take this action. And you could have an action that's just alert only, or it could be an action that's alert and block, or it could be alert and keep snapshots and retain the snapshots for a period of time. So once we send that information to you, you can then say through the API, I want you to take this action, like stop this user or block this account.
Yeah, so they can say, I agree, there's enough signals here, go ahead and lock it.
Exactly. Yep. And especially if you're going to have, we have one view of the network, right? You could have information from a lot of sensors and saying like, well, that person's not at work today or is at work, and put that all together and then say, hey,
or this person's doing a project that he's accessing all kinds of stuff all rapidly.
So ignore it.
To collect it, and it's legitimate, and blocking him is the worst thing that could happen right now because there's a reason he needs all this.
So only, can you elaborate a bit on your alarming and actions? Yeah, so that is based on threshold. I say, if a user is doing certain amount that is abnormal, then I want to investigate. And then I can do this user specific. So that means, I don't know, user A can do 100,000 operations and the normal user can maybe only 5,000 operations an hour or something like that.
Currently, we don't do different levels for different users. Currently, it's per data set. So you choose per data set what you're considering normal. And we have file activity thresholds for reads, separate one for writes, and a separate one for deletes. And you can choose, you don't have to enforce any of them, or you can say, I want to enforce just alerts, or you could have a threshold for alerts and then a threshold for blocking. And so you can choose what you want to do, but we don't distinguish the user. The only thing that we do that we distinguish that I'll show you is that if you're using an administrative or privileged account, we immediately flag on that differently because we don't expect admin accounts to be used for kind of normal file operations.
And can you share with us, if I would set up a ransomware on your system, and start now encrypting things, how fast is the system detecting that, and when will it actually stop that?
So I'm gonna
obviously malicious behavior,
And I saw there was a speed test today. They were like speed testing different ransomware, how fast they could encrypt data. It's pretty fast. I'm actually going to show it to you, but I'll give you a little background on it. It depends on which strain of ransomware it is. Certain strains we can detect very quickly because of how they behave. Certain maybe generics or ones that we haven't seen, maybe it's a 0-day. There's still behaviors we look for. It takes us a little bit longer to build up confidence to say that's a ransomware attack, but it's still like minutes and potentially even seconds. So we're able to do it very quickly and then show you what files we believe are around the incident.
So I assume a bit more easy to detect is somebody like a Viperware, which is just doing staccato as fast as they can. The one that's going a bit more slowly approach is harder to detect. Yeah,
it can be. It depends though. There's lots of things we're looking for, and the one advantage we have over kind of other systems that try to do this is that the data is stored on us, so we know about the data, what it looked like before, what they're doing now, and what doesn't look right, and the normal way most applications open up files and how they write files. And so when those things don't all match up, we can leverage all that together to put a better picture together more quickly. But it's not perfect, but I feel like we're in the best position to be able to do that. So, yep. So let me show you the insider threat demo, and then I will. So you saw me going to here. The one thing is we can allow admins to actually restore files for users without being able to see the contents of a file. So this allows them to basically restore a previous version of a file from our immutable snapshots without having to see sensitive data, which is valuable. And the data is indexed so they can find it quickly. So I can restore a previous version, for instance, of this sensitive flight plans file even. And when I do that, I'm also going to I'm going to go over to here, and I'm going to try from this virtual desktop over here to use my admin account. You're going to see I'm going to log in with my admin credentials. and go look at the file that I didn't have user privilege to look at, but am kind of curious about. All right, so you can see, I see that over here. I'm going to restore a previous version of the sensitive files from over here. So I'm going to restore this for the user that requested it. It's going to show up now over in this data set. So you see that? So I can't read that, let's say. I'm going to go over to my virtual desktop over here where I have an admin privilege, a credential, and look at that. So I'm going to open up just to see what they had me restore. So now I've seen this data. I'm like, oh, it wasn't as exciting as I thought, but immediately what we're going to do is we're going to alert over here that an admin credential was used for this. So we can see admin access by my jhalstuch.adm account, and basically 2 files got hit. So I'm going to let them know that I'm looking at this. And just to show you also, I had this demo here where you can actually see I'm sending webhooks to Teams so you can see what's going on and the information about the event. So I acknowledge I'm investigating this event about the admin access so we can figure out if that's good or bad. I can then go into here and see which files were touched. So I had that normal, my desktop reaching out, but then you can see my sensitive flight plan file that I opened up. And so immediately you could start to investigate this. Think about back to the Sunburst SolarWinds. You see the Sunburst SolarWinds network monitoring software reading a bunch of files, and it's coming from the Network Orion monitoring. You'd be like, something's up here. You could immediately take action and start investigating that.
Is there would I be able to set like a if something unexpected like that happened, it could auto block it, or would it be, is it something you would alert and I would action?
This one's set to alert. However, we do have a rules engine. So that's kind of, if you go into the incidents here, we have these rules. So out of the box, we have a set of rules defined and confidence levels and thresholds. But essentially, if you're used to firewalls, this probably makes a lot of sense to you. But essentially, you can add rules and change behavior. So based on different things, you're able to choose what's going to happen. And you can kind of create a time period. So if there was like a period of time where we're going to allow this user to do work, you can in advance say, okay, I'm going to allow that person to have a period of time where they're allowed to do work. I'm not going to block them. And then take it away at the time when that change window's over. So
that comment that you made about timed, so I'm guessing what you meant is like for this amount of a week or something,
a particular time. So like you could say,
but would you have a like could you also do a timed like business hours? So if somebody's logging at 2 a.m., that's a little bit sketchy. Yeah.
Those are things we're planning. We don't right now. It's kind of a 24-hour. It's all the rules, but I think where we're going is like, after hours, off weekends, and in user behavior, we do have filters that will show you like, here's what happened after hours, and you can filter on that. Here's what happened on weekends, and then look to see like, well, who was working over the weekend?
Yeah. Would your behavior? I'm assuming you do like behavior analytics, right?
Yes.
Would it be like this is what's normal for this user, but then this is outside normal?
This is where they're
people like maybe the parents might be working at really weird hours.
Right. And that's where some of the graphic stuff goes well, because you can see like week over week and month over month and visualize it. And so some of those tools are nice, and then feeding them into the dashboard and you can kind of look at it. So, so the good thing is all that information's there. It's very high fidelity into like, are they like how many files per minute, or are they looking at the whole file? How many files are they writing? How many are they reading? So it's there. And then you can get some interesting insights. Even when we first started doing this, the most interesting thing was the user logins. You'd see their profiles. You could tell when somebody's logging in because you could see exactly what's happening. They follow this normal pattern. And you could see when things weren't normal just by, like you're saying, this is kind of what I expect to see when. So now I'm going to show you a ransomware attack. So I'm going to basically start playing a video from this virtual desktop. So I'm going to play this video over here. So it's going to play on this. Then from my laptop using, so over on that one, it's that ADM account. On my laptop, I'm using a Johnny account. So I'm going to play that video. I'm going to loop it. So now you can see I'm playing both videos at the same time, but unfortunately we're gonna act as if my machine is infected with ransomware. So I'm actually gonna launch a ransomware attack against against the BrickStor from my desktop. What you're gonna see is that it's gonna stop me, but all the other users will be able to continue to operate as normal. So looks like it's a little slow over the VPN though. So you see it's going out there, it's looking at the data, and then essentially once it tries to encrypt it, it's going to block that user and account. It's not as great. So you can see it stopped there. So we detected the ransomware attack, so it stopped the video there. And if I try to access any further data on this, it's going to say I'm not connected anymore. So I can no longer access data from there. So now we know there's an attack. So if we go back over here, we look at the security incidents. We have a new security incident, which is we detected it was a Ryuk ransomware attack from my Johnny account, and that's the IP of my laptop. So I can acknowledge, again, we're working it.
So, but the end user, they're going to see just a Windows.
They're basically, yeah, getting stopped.
Yeah, everything just
Yes.
dies right there.
Well,
in
this
the
is
hell.
where they call the help desk and like, my computer's not working.
Yeah.
And then they can't get to the network engineers. Doesn't work.
It's a network's fault.
Yep.
Which is why you want the
rebooted twice first.
This solution has to, like, it's aware of certain ransomware attacks. Like, there's already ones that it's going to know what's predetermined behavior, or other ones it's not. With the analytics, so how does that work? And I'm sure, it's not instantaneous, but over time, like, how do you guys pull that on your end?
Yeah, so we're
to train it to
exactly. So there's kind of pattern files that we can update the system with, and they'll come down over the wire automatically.
Oh, okay.
And then also, so those are for like known ones that we know about and we have information about.
Yeah.
But we also have a generic assessor, which will figure things out too. So it might not build up enough confidence as quickly as like a Ryuk one, which is like, we know this is exactly what Ryuk does, but eventually it would catch it. And you're still within like minutes, not, days or anything like that.
Oh, okay, cool.
So how much damage gets done in a couple minutes?
In a couple of minutes, you're going to hit a couple files. I haven't seen anyone, when we've been testing this out, I haven't seen them go minutes. It's usually under a minute. But the most people are able to encrypt, depends on how strong their encryption is and how good their connectivity is. So, but it hasn't been too damaging. And the other thing is, though, this is the cool part. So let me show you this. So in this case, it only got to one file before we stopped it.
I mean, I'm not a malware specialist, but my understanding is most of it does a certain amount of indexing, and it has a file where it's only going to encrypt certain file types based on the malware type. And so I'm assuming how much gets encrypted depends on the flavor of malware and what that dictionary looks like that it's matching.
Exactly. Like if it's a lot of small Word documents versus images, it's going to go a lot faster to get but the other cool thing is we might even pick it up before the ransomware part because we do have excessive file activity. So if they're reading and doing all this, like kind of casing the joint and reading a bunch of files, we might stop them before when they're stealing it. Yeah, exactly.
Because the encrypting part is at the end of what it does after it's done everything else. Okay.
Exactly. So hopefully
chance.
Yeah.
Right. So hopefully we've gotten them when they're trying to steal the data to extort you. We've stopped them then. If we didn't, then you get to the ransomware, they encrypted it. So this is kind of the last part. And so in this case, it got to one file before we stopped it.
It has a versioning of the file. The admin account had a new version that was encrypted, but the other users were still referencing to the older version, the non-modified version, so they could still access it. And this is why you more or less maintain for the other users the accessibility for the file.
So the versions would change. Everybody would see the new version. If they encrypted that file and wrote an encrypted one, everyone would see the encrypted version of the file. And if they delete it, it'd be gone until we restore it. The difference is that we prevented the other user that had the bad software from seeing any files anymore. So he's blocked. Every other user, like this admin, or if there was some other user, Dave over there, they would see that file. They would see all the files that were there. Typically, though, they can't, like ransomware is not going to be able to encrypt the file that's open. So if you're actively working on a file, they're not really typically going to, because it's locked. And so you can see this one got that the RYK file and it matches there. So I can basically restore the file, the original version out of those immutable snapshots. So it pulls that back out there. And then I can delete the bad file and clean it up. And so you can see the encrypted file was removed and we restored the good file that was touched before afterwards with the out of the immutable snapshot. So it just makes it easy because you can actually see, what files were affected by that account. And you have this whole report here. So now I can see I'm still blocking my laptop. We're still blocking my user account, the Johnny demo, and we're still holding the snapshots. So if we have to recover any files out of there, once we were satisfied everything was cleaned up, I could just lift certain actions. Like maybe it's just my machine that's bad. So we want to allow me to go work at a different laptop. So I could log into a different laptop, will block my host and keep the snapshots, but not block the user. Or we can lift all the actions. So I can unblock me and even close the incident. And basically we will see that I can once again access data on here. So I'm gonna, if I try to access the folder again, I can, and then I can actually play the video again. So,
What was the last thing? Could you read? I'm sorry.
Yep.
I missed. I was taking a note. Was it, so when you went ahead?
so I lifted the actions. So you can see
Okay.
we listed the actions that we performed. So in this particular, for ransomware, we block, it was closed, sorry. You can see the closed incidents.
Okay.
So this one, we blocked the user and then we blocked the host and we held the snapshot so that you could restore any files that might have been affected before the incident.
And then to lift it, is there?
Yeah, you basically right through here, there's a button that just says lift actions and you choose which ones you want to lift.
That's what I mean. Thank you.
So it looks kind of like incidents. Do you have tie-ins with like ServiceNow and other ITIL management?
We can feed to them, but we don't have, that's something we definitely want to be able to do in both directions so that we can create help desk tickets. And we could easily create a help desk ticket with webhooks through ServiceNow, but going the other way, we don't have any direct plugins yet.
Yeah, I thought I saw a slide earlier that had SOC or SIM integration.
Yeah.
SIM sort of,
Splunk and Elk, yep.
which is different than ServiceNow.
So is this is the
I'm curious.
platform?
I'm curious because I know that you're low on time. From a deployment standpoint, because I'm thinking like a lot of companies, they might have a NAS on premises already, and it's just filled with crap data. Is there a way to help them deploy and also go? Because I'm thinking like if we're talking about different types of data, you can do it at the folder level, but if their data is already all over the place, that's not going to help.
Right. Basically, you can start to move data onto us and we can deploy. The cool thing is we can deploy in various ways. We can deploy as a virtual machine. So if you already have infrastructure, you have a NAS, you could deploy us instead of your Windows file server or your Linux file server, you can start to consolidate onto us, deploy us as a virtual machine. If you have a large scale type of system, we can sit in front of existing enterprise block storage and turn that into Cyberstorage.
So it's not a rip and replace. You already have a NAS or SAN.
Yep.
You can actually put it in line
Yeah,
with
and most of the time that's what's happening. Yeah.
Okay,
I
that's cool.
have one more question.
Yep.
Because I see Tom creeping.
You got one more question.
As somebody who out of the world of 30 years in IT, I think storage is probably my least level of competency. Without naming names, I'm curious, what do you see as your key differentiator that you guys do differently or better than other solutions?
So all the other storage just stores your data and they have access controls. We're the only solution that has active defense that can actually detect malicious or suspicious behavior and respond to it. So like that whole zero trust is unique to us.
Okay.
We're leading in that market.
I love it.
So, and you can even try, if you want to try it out, our Jumpstart program, you can go to our webpage, download software, you get free support for 90 days, free, all the features are included. We'll even help you install it and you can see how it works in your environment. So.